All right, so we talked about potential energy in general. We set up how the change in potential energy is related to negative the work done by a conservative force. So when you have a conservative force that does negative work, you're basically increasing the potential energy and therefore able to store energy that you can get back later. We said there's two particular potential energies that we'll deal with in this class. One is gravitational potential energy, the other is elastic potential energy. So let's talk briefly about each of those and set those up. So first, for gravitational potential energy, well, let's start by thinking about gravitational potential energy in a constant gravitational field which points downward. So basically, if I'm dealing with the gravitational field at or near the surface of the Earth, so what does the gravitational force want some mass to do? Well, basically, it always wants to pull the mass downward. So if I take some object and let the gravitational force act on it, I know the gravitational force is going to pull it down. If, on the other hand, I lift that object up so that it does the opposite of what the gravitational force wants it to do, then I'm forcing the gravitational force to do negative work here. Right? I'm doing positive work, the gravitational force does negative work, and so therefore I'm storing energy within potential energy when I do that. So this tells me that I increase gravitational potential energy when the mass moves up. Right? So I'm increasing the potential energy by lifting the mass. So I do positive work, the gravitational force does negative work, and that causes the potential energy to increase. On the other hand, you decrease the gravitational potential energy anytime a mass moves down. So when I let a mass fall, that potential energy that's been stored up is being converted into kinetic energy so that the mass falls faster as it goes, and you have less potential energy at the end than you did at the beginning. Obviously, if I move my mass horizontally so that it stays at the same height, I'm not doing anything to change the potential energy. So the gravitational potential energy remains the same when you move a mass horizontally. So in terms of the calculation, well, basically we've already done the work here because we've already calculated the work done by the gravitational force, and so we know that all this is going to give us at the end is just a negative in front of this answer. And so sure enough, when we take care of the signs in the dot product and do our integral correctly, we end up with mg delta y, where m is our mass moving in the gravitational field, little g is the magnitude of our gravitational field, 9.8 meters per second squared, and then delta y is our vertical displacement. And again, because we picked the positive direction for y to point up so that we knew that our force was going to have a negative component. This means that we've built this with a positive y, or delta y will be positive when our object moves up, and it will be negative when our object moves down. So just like when we were talking about the work, it is convenient to basically redefine things here so that instead of having a plus or minus buried in delta y, I take care of the plus or minus out front, and then I'm just multiplying together three positive scalar quantities so that I have m, g, and then delta h is just the distance that my object moves vertically. So I'll use the positive because I know I'm increasing the gravitational potential energy when my object moves up. I'll use the negative when my object moves down. So to check and make sure, we said that we increase the gravitational potential energy when mass moves up. And sure enough, whether I'm picking a positive delta y here or the positive sign in this equation, that holds. We decrease the gravitational potential energy when my mass moves down. So if I'm choosing to calculate it this way, I've got to put the minus sign in the delta y, but that makes the change in potential energy negative. Or if I'm moving my object down, I'm just going to go ahead and put the minus sign in to do my mg delta h calculation. Either way, again, it checks out. And then I know that the gravitational potential energy will remain the same when my mass stays at the same height. And so, well, if it stays at the same height, either delta y or delta h are 0, and in that case, the change in the potential energy is 0. So sure enough, that checks out as well. So if you want to talk about the potential energy, So the potential energy is really just a short form of saying the gravitational potential energy relative to the point where it equals zero. So in our constant gravitational field, we get to pick the point where the gravitational potential energy equals zero. And so what we will often do is pick a low point, maybe even the lowest point within the problem, to be the 0 point. But we can pick anywhere we want. Once we've made that choice, then we can calculate the gravitational potential energy relative to that 0 point by either being plus or minus mgh, where here h is the distance above or below the 0 point, and we use a plus if we're above and a minus if we're below. So as an example, if what I did was I picked this particular point in the field to be the 0 point. So I'm going to say the gravitational potential energy equals 0 at this particular height. Then when my objects move around, right, so initially this object had a positive potential energy, but it's moved to where it now has a final potential energy that's 0. On the other hand, this object, it's starting with an initial potential energy that's 0, and it's moving up, so its final potential energy, since it's now above the 0 point, will be positive mgh. Obviously, if I moved either of these objects below my 0 point line, say all the way down here to where the arrowheads are, then there would be a negative gravitational potential energy at that point, because I would need the minus sign because I'm below the 0 point. So if you're at the 0 point, potential energy 0. Above the 0 point, potential energy positive. Below the 0 point, potential energy will be negative.